So in the last video, we looked at a condition for invertibility. We said that A is invertible precisely when, or if and only if, A is row equivalent to the identity matrix. And if A is row equivalent to the identity matrix, the sequence of row operations that reduces A to the identity also reduces the identity to A inverse. So this leads to an algorithm for finding whether or not A is invertible or singular. And then if A is invertible, you can find A inverse using this algorithm. So this first step, why in the world is that red? It's black and it's saying it's red. Or rather, it's red and it's saying it's black. Okay, number one. The first thing you're going to do, you're going to set up a mega matrix, A along with the identity. And you're going to row reduce that. And when you get R with C on the side, a mega matrix RC. What's R? R is going to be the RREF, the reduced row echelon form. So this R here is the reduced row echelon form of A. It's what happens when you super reduce A. That's what R is. So two things can happen. Either R could be the identity or R may not be the identity. So if R is not the identity matrix, well, if A does not reduce to the identity matrix, then A is singular. It's not invertible, right? Then A is singular. And you don't have to worry about finding an inverse because if A is singular, there is no inverse. Or the other option could be A reduces to the identity. So if A reduces to R, and if R is the identity, then that means A is invertible. And remember that the sequence of elementary row operations that reduces A to the identity also reduces the identity to the inverse. So that would force C to be the inverse. So thus, C would be equal to A inverse. So that's how you find A inverse in general for an n by n matrix. So we know how to find A inverse for a 2 by 2, so this allows you to find it for any size matrix, like a 2 by 2 or a 3 by 3 or a 4 by 4 or a 5 by 5. So let's do an example where we actually calculate inverses or determine invertibility. Exercises. Determine if A is invertible what the heck? Why does it switch to, it says black, but it's writing red. Determine if A is invertible, first of all, or singular. If A is invertible, find A inverse. All right, number one. So here I have a matrix A consisting of what? 1, -1, 0 down the first column, 0, 1, 1 down the second column, -2, 0, 1 down the third column. So what I'm going to do, I'm going to set up a super matrix, a mega matrix, A with I3. A with I3. Right, we're going to use I3, a 3 by 3 identity matrix since A is 3 by 3. This is going to give us a 3 by 6. We're going to have 1, -1, 0, 0, 1, 1, -2, 0, 1. That's A. And then to the right of that, we're going to have the identity. 1, 0, 0, 0, 1, 0, 0, 0, 1. So at this point, we're going to row reduce this. We're not going to do this by hand. We're going to use our calculators. Doing this by hand would be taking an incredibly long amount of time. So you go to second matrix, edit, put in 3 by 6 for your dimensions, and enter the matrix. 1, -1, 0, 0, 1, 1, 0, -2, 0, 1, 1, 0, 0, 0, 1, 0, 0, 0, 1. Quit. Then second matrix over to math. RREF, I'm going to enter that. Second matrix, highlight that first matrix, press enter, and that gives me my outcome. So you can use a computer for that, or you can use your calculator. I'm using a TI-83. You could TI-83s, TI-84s are really common for this. So my outcome here is, let's see, 1 0 0 0 1 0 0 0 1, and then 1/3 1/3 negative 1/3 negative 2/3 1/3 negative 1/3. The third column, or the last column, actually this is the sixth column, right? 2/3 2/3 1/3. So first of all, is A invertible? Yes, A is invertible, right? This was A right here, and it reduced to the identity right here. So since A reduces to the identity, then A is invertible. That's the first part. So since it's invertible, then that means that the identity matrix right here will reduce to the inverse, which will be here. And so thus, A inverse is this guy over here. 1/3 1/3 negative 1/3 negative 2/3 1/3 negative 1/3 2/3 2/3 1/3. Right, that's the inverse. That's called the C or A inverse. And that's how you find an inverse, if it exists. Okay, let's scroll and let's do another problem. Hey, it's writing in black this time. Let's say I have A is 1 2 0 0 negative 1 1 and 2 3 1. So I'm going to write down a mega matrix A augmented with I3. Why I3? Because A was a 3 by 3. So we're going to have what? 1 2 0 0 negative 1 1 2 3 1, and to the side of that the identity I3 1 0 0 0 1 0 0 0 1. We're going to row reduce this. RREF using your calculator. Okay. When I row reduce this, I plug this in. I am plugging it into a computer program online right now. It's 1 0 0 0 1 0 2 1 0. Okay. 0 0 1 1/2 0 negative 1/2 1/2 1 negative 1/2. So notice here that A, that's A right there, I'm underlining it in yellow right now, that reduced to something. That something here I'm underlining in yellow, that's the RREF of A, the reduced row echelon form of A, but it's not the identity. So because it's not the identity, so since A does not reduce to the identity, that means then A is singular, it has no inverse. So you don't have to worry about finding an inverse. This guy right here is not the inverse because A did not reduce to the identity in the first place. So, okay, so I think we'll just quit there. So that's how you find, that's how you determine invertibility. Just an algorithm for it, and finding inverses in general for larger